Hi, my name is Dan, and I work on the React Core team. In December, our team has published a talk about our research on the new experimental React feature called React Server Components. If you haven't watched this talk, you can find it by searching data fetching with server components on YouTube. The talk was an introduction, and like we said in the talk, we'd like to follow up with more in-depth content. So this is why today we're recording a Q&A where a couple of people from the React community will ask questions and a few people from the React core and data teams will try to answer them. Our initial talk about server components was a high-level overview aimed at everyone using React. However, quite a few people working on the front-end infrastructure at different companies expressed interest in a deeper, more detailed conversation about how server components fit into their app's architecture. This Q&A is an architectural deep dive. You don't have to watch it if you're only using React as a developer, but you might find it interesting if you work specifically on front-end infrastructure. This Q&A assumes that you've already watched our talk called Data Fetching with React Server Components. It also assumes that you've already read the Server Components RFC and played with the Server Components demo. So we're not going to explain what Server Components are. Without further ado, I would like to let our two guests introduce themselves. Our first guest is Jae. She works at Find My Past. Jae, can you tell us a little bit about the kind of work you're doing and what got you interested in server components?
Yes, hello. Yes. So I'm a principal engineer at Find My Past in the e-commerce team. So we do all of our payment and account management flows. And so the thing that interesting about payment components, all our app is in React, and any new development we do there. And so anything which can help development, and especially data fetching and secure data fetching is something that's of great interest to me.
Thank you. And our second guest is Yan Wei. He works at Pinterest. Yan Wei, can you tell us a little bit about what you do and what got you interested in server components?
Sure. So my name is Yanwei. I work at Pinterest on the web platform team, and we're basically a vertical team that supports web developers across multiple product teams at Pinterest. And we're interested in server components primarily because A, we do a lot of server rendering at Pinterest, and also B, like data fetching and sort of how you fetch data across client and server is something that we've been thinking about a lot lately. And so server components just kind of really sounds like it would solve a lot of our issues.
Thank you. Finally, I'd like to introduce our guests from the React Core and React Data teams. We have quite a few people today here in the hope that for every question, we'll find somebody who can answer it. So let's go in the alphabetical order. Andrew?
Hi, I'm Andrew. I'm on the React Core team. I guess in particular, I work on a variety of things, but concurrent mode and suspense. So the stuff that happens once it hits the browser, basically.
Thank you. Joe Savona?
Hi, yeah. So I work on the React Data team, primarily working on Relay, but also collaborating with the React Core team on things like data fetching with suspense and server components.
Lauren?
Hey, I'm Lauren Tan. I am an engineer on the React Data team along with Joe. And my work has been primarily focused on augmenting Relay with support for server components and also prototyping its use within Facebook.
And Sebastian?
I'm Sebastian Markbage. I work on a React Core team, and most recently, mostly on the core implementation of server components and streaming server rendering.
Thank you, everybody, for introducing yourselves. And before we start, I want to emphasize that server components are still in research and development. So we ask that you don't create courses around them and don't build your apps with them yet. The purpose of this Q&A is to be more transparent about the future of React and its development, but we don't have all the answers yet. And so the answers that we'll give here are not final, and they just represent our best idea at the moment. So I think now we're ready to jump into questions. Yanwei, do you want to go first?
Sure. So we played around with server components recently, and actually were able to integrate it into our app just to play around with. And I think a lot of people on the team were really excited. But the first question that sort of popped into everyone's mind was, when is this actually going to be available for us to use? And what are some of the big missing pieces that are sort of left before we can actually use this?
Yeah, I think there's a couple of big pieces. Everything about server components connects both to server rendering and the client, and specifically the part of how suspense works. So there's a few missing pieces in our server rendering story. So we're currently working on a new implementation of a streaming server renderer, which has some new interesting features, but particularly that's how we plan to integrate the data stream from server components, so that you will be able to server render together with into HTML together with server components. The other parts that are kind of missing is we want to make sure that when you're bundling the output, so server components kind of implicitly gives you this fine-grained bundle splitting built in. But we want to make sure that there's a particularly useful bundling strategy that doesn't just regress the strategy. Because if you're splitting your bundles into two small pieces, then that can be worse than not splitting them at all. So we're working on at least providing a prototype, or ideally a full implementation of a Webpack plugin that will let you have a pretty decent out-of-the-box experience. And there's other ways you can do that, and I'm interested to see kind of what the community comes up with various types of bundling strategies. But we want to at least be able to ship our best thinking so far in this space. And then there's another piece, which is how does this connect to the API you use for actually kicking off the fetch, like routing or pagination or other things like that, that we don't necessarily see ourselves being particularly opinionated about, but there's certain patterns that work well and certain patterns that don't work well. So we want to at least provide a prototype and a demo showcasing how you can think about solving those problems.
I don't think you answered the when part. Do you want to comment on that?
Yeah, I think so. We're working towards having a release candidate of the client aspects, and we're hoping to kind of introduce both the new release for kind of a React 18 version together with a server components MVP and possibly some streaming rendering as kind of a preview package, hopefully this year.
Thank you. Jae?
Following on from what you said about how it ties into server and client rendering and data fetching, our app is built around GraphQL, and specifically Apollo GraphQL, and which means it's built around this GraphQL cache that is warmed during server rendering, transferred to the client, and then on a user's journey through a session, that cache gets modified by new queries and mutations. How are you thinking about things like this, things like a GraphQL cache that right now is shared between server and client? Are you planning on making something like that work with certain components, or is it something that the ecosystem and us as developers will have to rethink how we interact with data in that way?
Yeah, I can kind of try to answer that. So yeah, I think we kind of see it as a sort of progression of how you might kind of evolve your app that uses GraphQL or even other data fetching approaches. So sort of the sort of first step is, I think, to go from non-suspense based data fetching to using suspense. The idea being, instead of fetching in a use effect or something, to switching to suspense based data fetching To make that work with server rendering, that would kind of require some of the pieces that Sebastian talked about in terms of the new suspense and streaming aware server rendering work that's going on. That's kind of like just like the first piece, and what that gets you is the ability to mostly keep the same patterns that you use in your app today, and to continue doing server side rendering. Then but the thing is that sort of gets you at multiple points in your tree, and to have all those all those queries sort of happen on the server without avoiding round trips for your initial page load. And then but what that doesn't really kind of solve is now you're on the client and now you want to like do a page transition or something. Now you're kind of going to be back in the world of you start rendering and maybe you hit multiple queries as you're rendering your app, and those could cause waterfalls. And so that's where we think server components can help. But that's kind of a second stage after you've kind of moved to suspense with data fetching. And to kind of like in terms of the broader question of how does GraphQL or other like kind of normalized data stores fit into the server components world? We don't foresee that like really going away. There are going to be parts of your app that have that are interactive, that require data consistency on the client, and those will continue, I think, to make sense to build with the existing the approaches that we're all using today. And there's lots of good approaches, GraphQL, REST, and various different data libraries. I think what's really going to change is for the parts of your app that make sense to convert to server components, you start to want to think about splitting up what's sort of state and what's the sort of canonical like server data a bit more. And others may have more that they want to add there.
I can add that I think that the strategy in general is like you need a suspense. All this builds on a suspense API, so that you have to build that regardless. And we expect a lot of these libraries that exist today to build some kind of support for that out of the box, and that lets you do the server component approach, and including co-locating your data fetching in your component without the waterfalls for initial load. But if that co-location or that transformation could cause a regression compared to what you're doing today, if you have a very optimized solution, and then server components could be the solution to that. So sometimes I suspect you'll actually want to wait to roll it out, even though that it's a two-step adoption process, until you have both pieces, just so that you don't regress performance overall in the meantime.
Jae, do you feel like this answered your question?
Yeah, I think that's quite a good answer, a lot of detail. I guess just to make sure that I'm understanding correctly is that we're looking at the components that are server components will not be updating in response to updates in the cache. So we're looking at server components being things that are rendered using kind of canonical data, like data from a CMS or something, but not things that are part of interactivity, and those things would be client components.
Yeah, exactly. And I think so. What we found is I don't think it's necessarily that the data that you fetch in server components, like that might very well come from GraphQL. It might come from the same data source that your client components are fetching data from. But there's often like data with within the data that you fetch, some of it changes at different like regularity. For just to take like the Facebook example, perhaps the text of a story that might not change very often, especially if it's something that you like, a post that you haven't written. And so the only time that you're really going that data is going to change is if you actually just refetch the whole story to begin with, at which point you're going to the server, you could just refetch the actual server component output. And so there's just different types of data, and so some of it kind of changes at this like less frequently, and therefore you could just kind of refetch it in full. And when you do, you just refetch the server component instead of fetching the data and then re-rendering it client side. So it's kind of about the sort of rate of change of the data and how consistent it has to be.
I mean, the adoption approach is a lot. The way to think about it is that you're writing a client component first, and then if you see that that component doesn't have any state or effects, you can convert that to a server component. But it doesn't have to be that you kind of go all into converting a whole tree or a whole subtree of components. It can be that you're just converting individual components as you go. So some of them in the tree might be fetching it client side or as part of initial server rendering, and some of them might be server components embedded in one tree.
I was going to add to Jay's point about certain highly interactive, like a theme here is that there are some components that don't update very frequently. And there's other components that are like highly interactive and have more like local state, like UI state, that's not as, maybe it receives data from the server, but like you can pass it in with from a parent component. So a lot of folks today who are already using a data framework like Apollo or Relay are probably already writing code in roughly that pattern, where there's some sort of separation between super highly interactive client components versus things that are really about managing data and passing it down. So that pattern works really well with server components. But there might be some folks who are just kind of throwing everything into the same kind of source of state, maybe like a store or something like that. And those patterns might take a little bit more work to migrate to this world where you're kind of thinking a little bit more carefully about what types of data that you have.
So kind of going back to Sebastian, what you said earlier about the streaming server rendering, I was wondering if you could talk a little bit more about that. As I mentioned before, like we care a lot about server rendering, and I think I was specifically curious to understand how you're thinking about the interop between client components and server components, client components, and server rendering altogether.
Yeah, so for server rendering, there's a couple of pieces where we're building server rendering with the suspensy approach in mind. So that is decoupled from server components. If server components didn't exist, that would still be a thing. And that approach allows you to stream chunks of HTML in if you have, for example, one slower data source than another. So you can kind of see the UI progressively streaming as you go. And it kind of ties into the whole suspense approach in general. But then you can see that each of those client components could be converted to a server component. And what happens then is it's similar to what happens on the client. I think of the server renderer as more of a simulated client environment where the server component the server renderer is the thing that receives the original requests, but then it can request data just like the client can request additional data. And that data could be a subtree of server components that then gets fed into the server renderer that acts as a client and then streams out the resulting HTML. And then it also embeds the server component output in the HTML as JSON data. And the one key distinction there is that current approaches tend to embed data in its rawest form. So if you're fetching a REST API on the server, you might embed a REST response in your HTML for use with hydration. But the server component approach, we're embedding the result of the server components in the JSON, which means you're getting kind of denormalized and processed data in the output, which can sometimes be bigger but faster to render, and sometimes be smaller because you're just loading the data that you actually needed for that component rather than the whole response of the REST response.
I was going to say something that, because I personally find it very confusing sometimes even though I know the difference between all the pieces, just because the naming is very confusing. Because nowadays when people think, well, it's called server components, I already have a thing called a server renderer. Well, the server renderer must be rendering the server components, but it's actually like not quite that. The thing that renders outputs like HTML, like the thing we traditionally think of as server rendering today, before server components. In this new architecture, that thing doesn't actually render server components. It only renders the client ones, which is kind of mind-bending. It actually receives already, I see I'm even struggling to think of the words to use it right now, but there's like a layer that runs your server components. It sends that to a client renderer. And then there's two types of client renderers, one that runs in the browser and one that runs on the server. I don't know if I'm clarifying it at all, but there's this distinction there between the thing that outputs HTML and the thing that fetches the data and generates this streaming output that you can then turn into HTML. If that helps at all.
Yeah, so I guess in this case, the server render it's like the simulated client runtime, basically,
Yes.
right?
Yeah.
And so I guess kind of following up there, does that also mean that client component, the assumption that client components only run on this client is kind of false in that world?
Yeah, so that's another confusing aspect is there are certain components that, so yeah, by default, client components you think of as they do run on the node server environment and output like initial HTML, or they run like in the browser. There is a use case for like some components that maybe you don't even want to try and render the initial HTML on the server client renderer. Sorry, the server renderer. So we're thinking of like an API where you can just bail out and say, just don't bother to try and render this tree on the server, and we'll pick it up on the client, which is a pretty nice feature because it gives you like some granular control over which things are able to run in both environments and which things aren't. But yeah, in general, you're right. Client components in this world doesn't necessarily mean you can just like access window and all of these browser-only APIs. Like if you want to take full advantage of streaming HTML generation, then same restrictions apply.
In terms of naming, I think there's some other interesting ways of looking at it, because the server components is really about that utilizing the server for what it's good at, like local to close to the data and relieving some resources and having code already loaded. Whereas the server rendering is more like a magic trick. And I think that's a good way of looking at it, because it's just about rendering this snapshot that the user gets to see before he can interact with it. But hopefully, especially with like kind of progressive hydration approaches, it won't feel any different when you try to interact with it. But that's really the purpose of the server rendering. It's to provide this magic trick of a fast initial snapshot. It's similar to kind of how on like an iOS app where you can see a snapshot in terms of pixels of what was previously there when you start it, and then it actually starts. It's a similar kind of trick, like making it feel like it's starting fast. Whereas the server components is really about this is a permanent approach that helps navigations further down in the app and permanently avoids having to load that code.
Yeah, I like the snapshot. If anyone has like a good suggestion for naming, by the way, we're open to them. The snapshot thing I like because it reminds me of like a V8 snapshot.
I think one term I've been using in my personally is like bootstrapping. It kind of like bootstraps the page just so that React can like take over and actually do what it needs to. But yeah, it's the server-side rendering that gives you that initial skeleton to actually do anything off of.
Yeah, in Find My Past, we've often call it the pre-render, because server rendering made people think of like ASP.NET MVC kind of application. It's not really what it's doing, so we started calling it the pre-render because it is this kind of optimization.
Let's go to next question, Jae.
Yeah, so going into that, one of the things when I first talked about server components with a colleague that is a principal on the platform, like front-end platform team, one of the things that he immediately was concerned about was our server pre-render is already like quite a resource intensive piece of our stack, and that's just pre-rendering like once per session. And he was thinking, well, what is it going to be like? What are going to be the performance characteristics of this server component provider that is going to have to do much more work over the lifetime of a user session, both in terms of like connections and in terms of processing for the server components. And is there going to be any built-in optimizations for, say, caching or memoizing the result of server components that might be the same even for different users, or even for the same user across the session, like requesting it again and again?
Yeah, so I think just to address the first point there is it's unclear so far. Like, we don't have great numbers. It's not super resource intensive for us at Facebook so far that we've seen in comparison. And I think part of that has to do with just how resource intensive is your kind of REST API today, or like the processing of the data or the GraphQL endpoint. And the other part is that the server components subsequent requests are not necessarily as intensive as the initial server rendering, because it's only the server components and not the client components. And it's also a subtree. So we'll have this ability to kind of refetch the subtree, but it's definitely a concern that we want to meet by having that ability to refetch a subtree rather than kind of refetching all the data for a whole page when you're refreshing it. And to the caching point, we have some ideas about ability to cache subtrees in various forms. So the caching is always kind of tricky because you have to make sure that you can invalidate it properly. But it also ties into context, where because we have the ability to fetch subtrees, like I just mentioned, we want to preserve that ability. Then we'll also have the ability to cache those subtree responses within any particular tree. But we have to encode the inputs to that, which is, for example, if you're having an HTTP fetch or a file read or all the inputs that goes into this, other than just the initial props, or all the data that you read, need to participate and give us a way to invalidate it, whether it's a timestamp or a file watcher or a subscription approach. So we haven't quite figured out what the API for that invalidation is going to be, and it might be tricky to add after the fact. So we're still kind of figuring out, should that be something that is part of the kind of data fetching API contract from the beginning, so that you don't lose that ability later, or is it something that you can gradually adopt later on?
If I want to add that, I think at the client level, the server component response is also cacheable, I guess, determined by the needs of the product. So for example, like if you have a part of your application that is really static, then and the rate of change for the data that powers those components, like let's say a nav bar, so you don't have to re-render the server components necessarily if those initial server component responses are cached. And there's nothing really special or unique about these server component responses that don't make them easy to cache. So for example, in Relay, we do cache the server component response. And we essentially make use of that if the data has not changed. We just instead of refetching the server component, we just restore it from the relay store.
One thing to add is you mentioned that your server-side rendering, what you described as pre-rendering, is currently resource intensive. I think one thing to note there is that for certain libraries, if you're doing the only way to do kind of server rendering with like data fetching and use effect right now is to kind of so I know like certain libraries in the ecosystem are kind of doing multiple passes over the tree just to figure out what data the UI needs. And then once the cache has been then warmed up, then they can actually do like a full render. But obviously, like that's kind of doing multiple passes over the tree. So I think with Relay, I think, and so we kind of don't see that because we're actually fetching all the data up front. And I think one of the kind of benefits of server components is that it makes that a bit easier to do. So with server components, it makes it a bit easier to structure your app so you can actually kind of avoid the need to like walk the tree again and again just to figure out what you're rendering. Also, the new like streaming suspensey server rendering will actually be able to resume work fetching with suspense. We can resume work where we left off as opposed to having to kind of start over. So I think that even in terms of that, like that initial baseline of thinking of kind of seeing that pre-rendering today is maybe expensive. I think that might change too, right? It's not just about, oh, we're adding more work. It's actually we're like potentially making all of the work that you're already doing a bit more efficient as well.
I have a question there. Do you use where is your GraphQL implemented? Is that a JavaScript service or a different language?
So GraphQL is mostly in JavaScript, but it's a distributed graph. So we have a central Node.js server that proxies different requests for different parts of the schema to backend services written in a variety of languages, but mostly Node.
Yeah, I think the reason I asked is because there's some overhead in just the runtime itself, and if for example if you have a REST API today and the REST API is built in Node, you can kind of just add server components as an additional layer to the end of the same runtime. And similarly, if you have a GraphQL implementation in Node or even in front, then you can just add server components at the end of the same service, and so you amortize a little bit of the overall cost because you're utilizing the same service for both processing your data and processing your server components, because essentially it's just a data processing pipeline.
Yeah, so I think this is kind of a continuation of the previous question. So we talked about caching of server component responses, and I'm kind of curious if I think today something we do is we cache the resulting data in like a client-side store or provider. We use Redux on our app, but I'm wondering if like talking about Relay sort of the Relay store caching the responses for server components. Is that something that like React itself is going to be opinionated about, or is that something that's just going to be up to user land and sort of the needs of the product?
So you want to go? Someone else jump in? Oh, I thought I heard a breath. Want to go first, Seb?
Yeah, I was just gonna kind of tie it back to what I was saying in the intro of like the pieces that are missing. There's a piece here about kind of routing and triggering the fetches, which also includes the caching. And we have some ideas around how you might want to do that without any additional library, just like the simplest possible you can do, where you would have the cache. There's a kind of this cache primitive built into React that would hold it's actually both used on the server to hold the responses that you use on the server, and a cache that holds the response on the client as well. But the cache is also used for any ad hoc thing you might fetch on the client. So for example, like you might want to have images in there to support kind of like suspensey images technique, or you might want to have one ad hoc client request that also goes into the same cache. So that's kind of the basic approach, and that is root. We have some opinions about how that's rooted. It's kind of rooted in as certain subtrees have a lifetime in React, and that lifetime controls the cache. But then you can also build this into an existing kind of not that is more globally rooted, like Relay, for example.
Yeah, I was gonna I'll add that if you've ever played with Suspense, like the preview versions of Suspense that we've published in the past, we have very glaringly not solved this caching issue. We've kind of just given you like a recipe for how to like do a user space cache, and we've kind of just put a giant to do in front of the whole area of like how you do invalidation, or how you decide which parts of the tree need to be consistent. So the API that Seb is alluding to is kind of the thing that we are now going to have more opinions on. And so if you are using Suspense, there will be kind of this unified built into React API that cache that different frameworks can hook into. And so each framework might have different implementations for how it fills in that cache, but there will be like a unified pattern for this is how you should invalidate it, or this is how you decide which parts of the tree need to be refetched, or which parts of the tree need to be updated after like a server mutation or something. There'll definitely be additional layers on top of this that like a framework like Relay will have like particular implementation opinions on. But the kind of lowest level substrate of like where does the cache actually live, we will have an API for that.
And kind of to fill in like what the purpose is, this is kind of a deep dive. Like the purpose of that cache is kind of to provide a consistency for the subtree. So if you imagine like you're doing a fetch for server components, but your server components can layer in client components, and the client components might also do fetches around the same time to fill in the same cache. And the idea is that you can invalidate all of that as one unit, and all of it, you go get a new server request for fresh data, but you also go get client requests for fresh data as well for the same subtree. And it's all tied with that subtree in React on the client.
Should we go with the next question, Jae?
Yeah. So a bit to go into another thing that I think about, especially with how complicated it is right now for us with data fetching, is error handling. So I was wondering what your thoughts are on that. Sort of like, what if what if there's an error in a server component? What if there's what if the service providing the server component becomes unavailable? Is there going to be a way for the client to say something like, well, if you can't fetch this subtree, display this in the meanwhile? Or is it a case of like, if there's some subtrees that fail to fetch from server components, the app isn't in a state where it can continue rendering?
So I can start by kind of talking about the general mechanisms and how it can fill in with their best practices. But there's a couple of places that errors can happen. There's errors that can happen kind of in the runtime outside of React itself. And that's kind of more up to the infrastructure or meta framework to kind of handle those. And then there's errors that can happen as part of network. Just you don't get the response at all, or you get part of the response, but the connection errors. And then there's errors that can happen within the server component. So the thing that when there's kind of an intentional thrown error within a server component that happens on the server, there's two things that happens. One, you get to log it on the server so that you can kind of track this. If they don't even end up on the client, you still want to know that you have some kind of errors happening. The other part is that it gets embedded as part of the response, and then that component where it kind of abstractly, conceptually gets rendered in the tree on the client, an error is rethrown so that the client's error boundaries can handle it. And if an error happens because of, for example, you've gotten a piece of the response but not all of it, or even if you didn't get the response at all, the client runtime throws an error for all the pieces of the tree that hasn't already rendered. So if you've rendered kind of because remember this is a streaming protocol, so you can partially render the data that we already have, but the error happens in the places where it haven't yet rendered. So the nearest error boundary to those places is where the error gets handled. And then it's really up to the error boundaries to determine what to do with that, whether it should display the error or if it should retry that request.
Yeah, that's really good thing. That sounds very flexible, and like it will give us a lot of options for all of the different error handling cases that you have, and it sounds easier than how things are right now about errors in the server, errors in the client with Apollo.
Yeah, I think there's one thing that is a little bit tricky in this space, which is you might have a general purpose error boundary that just renders all of an error message for all the errors. But in this world, it might, if you're never using errors like IO errors to be thrown as an error boundary, then those boundaries might not be aware that they should handle special case IO boundaries, or maybe rethrow if it's an IO error. So it's a little tricky now that an error boundary now has to be aware of IO errors as something special so that it can know to delegate those or know to handle it itself. Because otherwise, if you have a deep boundary that handles the IO error, it might not refetch. Whereas if it would have bubbled through that error boundary, it would have gotten to a parent that knew how to refetch it. So that's still a little tricky, but I think it's pretty flexible still.
One thing we were curious about was specifically in terms of, a lot of our pages are basically giant feeds. And so pagination is something that we think about a lot. And I'm kind of curious sort of whether or not that, like how that would look like in terms of like server components and pagination and sort of fetching of subsequent pages, I guess.
Yeah, that's a great question. And I mean, I think being very honest here, we're not sure yet. We've like thought about this, we've explored it, but what currently, for example, we're using Relay for our pagination. So, for example, we're using server components for kind of individual items, and I don't think actually we're using server components within a feed like situation yet, but if we were, it would likely be kind of Relay on the outside, server components on the inside. And I think our idea is to kind of gradually kind of explore that space. So just in terms of like where we are, like a little bit to be decided. And I think one kind of challenge there is the need for and even with Relay, I think we're still kind of evaluating what is the right way to do streaming pagination with suspense, where you want to have new items kind of arriving from the server and getting kind of incrementally rendering, but obviously with suspense integration, so that you show like the first item and then subsequent items, even if maybe the second item is ready first, right? So it has to be kind of integrated with suspense list. So yeah, this is like a non-answer. Others may have more thoughts, but like that's kind of like the current state of where we're at. That like of what actually works and is known.
So yeah, I think there's actually like more known there than it might seem, because there's a bunch of possible versions that we don't think is going to work. We don't have the exact API, but we think roughly the same structure. So we've explored various forms. For example, kind of like if you refetch the whole page, it told the server to now include more in that list, would be kind of one approach. But the approach that we think is going to be which kind of probably seems the most intuitive too, which is you imagine each item in a list being its own subtree, and we will have the ability to refetch just a subtree, picking up the context for where you left off. So the idea is basically you have a client component that is managing the list, and it's sending a request for give me this list of extra items, and its server renders those, or server component renders those, and then you get that result back, and that's what you render at the end of the list. But effectively what we're doing really, there's nuances in exactly how you design that API, but I think that's the general principle. And some of the reasons for that particular approach is that the page itself is kind of stateful, in the sense that where you are in the list is kind of a client concept. If you just refetched, and this is especially true with Facebook, because the newsfeed, every time you refetch, you get a completely different order. It doesn't have any inherent order. So because kind of the underlying data can change, the list can change throughout time. So we don't actually want to refetch the list itself as part of this request. We just want to add like an extra page and just fetch that page and add that to the data we already have, right? So, and to do that, we need to be able to pick up the context. But which context should it be? Should it be the context of the freshest data, or should it be the context that you rendered with at the time that you rendered the outer list? And I think that it probably should be the context that you had when you were rendering at the outer list. So there's kind of a lot of things that we concluded, and the end result ends up looking a lot like relay pagination. So I would look at that as kind of the inspiration.
Yeah, that makes sense. Thank you.
Okay.
Yeah, so another another environment for all of this will have to run that me thinking about is in tests. So right now we have quite a few tests running the React against JSDOM for some quick tests that can be run more quickly than, say, like Cypress end-to-end tests that actually run a browser. So I've been wondering like how server-side components fit into that. Will it be a case of being able to have this server-side component provider running locally as part of the same process that is running the tests, or how do you imagine that?
I was going to ask Lauren, how do we run tests now at Facebook end-to-end? Can you talk a little bit about that?
Yeah, I think so. Currently in our prototype, we do have testing, but the only tests we have are basically end-to-end tests where we do actually run the server component rendering infrastructure in that test. I think the unit test story is still kind of at least not super clear to me. So others may have thoughts on that. But yeah, we do run our tests end to end, so we get to see, like the actual full end-to-end flow of rendering a server component and then making it into the initial load, and then like any interactions that might be expressed in the end-to-end test, like those are all testable there. So it should plug in, I think, into existing end-to-end frameworks, assuming that you can run your server component rendering infrastructure as well. But I think the interesting thing about server components is that I think there will be paths that we're exploring. Like we're currently researching some ways to run server components in a different environment, like not on your server, like maybe in a worker or something like that. That could, I guess, help with the unit testing. Sorry, but I don't know if like Sebastian or Andrew has more thoughts there.
Yeah, I think for end tests, it's well, so there's different types of unit tests. Like I don't always know what people mean by that. I think it usually means like some part of the layer is mocked out or stubbed. So like if you wanted to unit test a client component that expects like server component data, then that'd probably be pretty similar to today, where you just, instead of rendering it inside of a server component, just render inside something else that gives it props. If you wanted to unit test the server component itself, and like since server components can like render UI, right? Then you I think the way I would probably do that is actually run the like some like in process simulate the request environment and actually generate the output, and then feed that into the what are we calling it now, pre-renderer API, and then assert on the React output the way you would for a client component unit test. I wouldn't probably you probably shouldn't assert the actual data format that this spits out. So yeah, I guess it depends on what layer or what of the stack that you're trying to test. But even for things that I call unit tests, I usually find it valuable when you keep it as end-to-end as possible. So yeah, I probably wouldn't recommend asserting on anything except for like the final tree output, if that makes sense.
I'll add also that a lot of what we call server components are actually shared components, so they can run on either the client or the server. And one way, if you're just looking to test the logic and not the integration, is to just render them as a client, just like you would test in today. I do think though that our observation is that moving more towards the direction of end-to-end, whether that is more of a simulated end-to-end like a JS DOM environment or a richer full browser end-to-end test, seems to be the way a lot of things are going, because it definitely simplifies testing a lot of asynchronous behavior, like all of this is.
Yeah, I think we also agree, I guess, that the end-to-end testing, especially like full browser, removes a lot of complexities of setting up the environment. But they are still there's still a trade-off there in between, like in performance and how many tests you can write and still have them run performantly. So yes, specifically, I was wondering, this kind of we want to test just a subtree in JS DOM, and especially what happens if that subtree includes both server components and client components, and can that just be run in process in jest, or is it a thing of no, you have to spin up a separate server worker process that does the server component stuff, and then
yeah, that's a good question, just because of the infrastructure is a little tricky with this environment, just because with special case how imports are handled. So in general, the server can't. Well, we can ideally it's set up so that the server component renderer is its own process from even the pre-renderer bootstrap renderer thing. But you can run them in the same environment as long as they're built a separate module system. So for example, a lot of production environments for server rendering uses Webpack bundling before it's loaded in Node. And since Webpack has its own module system and its own graph, you can put two of those in the same process. But also, if you're able to run it as a client component, it's more or less behaves similarly. It's not exactly the same, but putting a client component where a server component would have been instead of a client tree is more or less the same. That's the idea, at least.
You mentioned towards the beginning that one of the things you're thinking about before releasing is sort of a Webpack plugin, and I'm guessing if I'm wondering if there are plans for first-class support for non-Webpack bundling, and also whether or not bundling on the server, for example, is actually a requirement for server client components.
Yeah, so we're doing Webpack first, but we want to support first-class bundling for any bundler that can support a good experience out of the box for this, for the client. There's a few constraints there, particularly the reason even the runtime is coupled to Webpack right now is because we're kind of relying on some internals to be able to synchronously extract and require modules lazily, even though they've already been loaded, and preload them early. So to get really the ideal performance, we're relying on a lot of these features that are not necessarily part of the standard API. But there's more other bundlers that support the same thing, so we can definitely support that. The other part is just getting the bundling strategy, which we don't really know exactly how that will work. But definitely something that could be built for others, and we could even maintain it as first class package if it's a high quality implementation, and we will happy to help with that. The other part of the question is whether the server part needs to be bundled, and none of this needs to be necessarily bundled as part of development. And I think there's like a large shift now in the ecosystem, trying to explore other ways of development where the development experience can be faster. For example, by not bundling, but we also think that an ideal developer experience for debugging could actually be to run the server part in a service worker, which might require some kind of bundling or at least some partial bundling or partial compilation to get JSX and stuff like that. But then even our demo doesn't actually bundle a server, and I think this is actually the big missing part, that it doesn't. And the reason I think it's ideal to do it, but you don't have to, is two things. One is that it's a little bit faster to just have a bundle running in the node environment in general. But the other part is we might want to use the graph that we determine during the bundling of the server to determine what the best bundling strategy for the client components are. So I know Tobias from Webpack has some ideas of even designing Webpack to have a shared graph between like a server bundle and a client bundle, so that it would have this information. But that really depends on what your bundling strategy is. But at Facebook, we use kind of a data-driven bundling approach where we see previous visits and try to determine using a statistical model how best to group certain client components are. But if you don't have that, you have to get as much information as you can from a static build. And a lot of the information is dependent on the server graph. So for example, if you have a server component that always pulls in these 3 client components, you want to be able to know that as part of building the client components, so that you know to group those. But you don't have to, because you can just build all the client components as a separate graph and treat all of them as entry points. But you don't have a lot of information then about how to group them best into the best chunks. But there's middle grounds here too. You could have something that doesn't actually run the bundling of the server, but just uses that as an analysis to feed into a client bundling. So, but I think the first approach that we want to build on the missing piece is a unified approach where the out-of-the-box experience is that you build a server first and you use that as input to build the client.
Yeah, so I was thinking about CSS as well, and with the server components will can render UI, and it's like how will the CSS get to the client at the right time when the server component UI is fetched, both in CSS and JS, and also like CSS modules kind of thing, especially if we're talking about how these server components might not, the code that runs them might never be downloading into the client. How does the client know to download the right CSS and put it in the right place?
I know this one. There's basically three different strategies of these that we observed. The strategy that we currently use at Facebook is basically a static analysis where we analyze the file and then we create the CSS bundles. They're basically one bundle that has all of the CSS more or less that you need. And in that world, you just have to make sure that the analysis is able to traverse these files so that it doesn't just traverse the client, it has to traverse. And that kind of ties into the previous question too, right? Like you have to have something that traverses the server files to find any CSS in there. The other strategy is more like in the out-of-the-box experience of Webpack with no plugin, where you can import a CSS file as part of a module. In that case, it's kind of implied that if you load that file, that the CSS file will be loaded with it. But there's no connection between the component. There's no explicit connection between the CSS file and the component. It's just that you import it and it's there. And that needs a little special consideration because that module won't be pulled into the Webpack client bundle, right? So the dependency won't be there in the graph. So that's part of the thing that we probably want to add in our official Webpack plugin, since that's a basics of Webpack feature. And we have to do something clever, like transform the file so that it injects the call, so we know that this file is associated with this component somehow. But the third option, I think, is a more common one, which is whether you do it statically or at runtime, there's something in the component that determines that this class name is associated with this component. And it needs to be injected. Either it needs to not download the dependency or it needs to be dynamically injected on the fly. And you can certainly do that kind of in like user space third-party code. But I think we actually want to expose a particular API for this case so that you can say that this is the class that I want to associate with this output. And if this output gets included in this part of the subtree, then there's some metadata that goes along with that in the server component's response. And then the client can inject that to load that CSS or to include that CSS in the server rendering. But I think that's going to be a missing piece that we'll have to add before it's really useful.
I just wanted to add something really quick, not specifically about CSS, but I think this is also like generally in the class of problems where some side effect that used to happen in the client now happens on the server. So you need some way to keep track of all the side effects that happen, like whether it's logging or an error is thrown or it's CSS in JS that's being used, and then be able to, like, depending on the needs of your product, replay that on the client, like in the error case where we rethrow the error, or yeah, like in the CSS case, you might need to I don't know, like request for that CSS or add some CSS class inject some CSS class to those components. So I think it's a very similar class of problem that I think we're working on.
Yeah, and we have a similar issue with Relay, right? Where we want to emit a data dependency, because we know from the server that we need this data to be part of the client component we're about to render.
Is there anything we should be doing today, to make it easier? Obviously, we want to be able to adopt server components and as soon as it comes out. Is there anything we should be prioritizing in our own code base so that, to sort of help that migration eventually?
Yeah. So there's multiple layers to this. We mentioned up front at the beginning of this chat that there is a dependency on some concurrent rendering features. So we've talked about this in the past before. Our next version of React 18, will support concurrent rendering, and so not all features of server components depend on you being 100% compatible with concurrent mode, but just by adding in suspense boundaries and starting to use server components in parts of your app, you're kind of opting in those subtrees into some amount of concurrent behavior. So we've thought a lot about this, and our rough strategy is that you'll upgrade your app to React 18, and basically almost nothing will change in terms of like if all you do is upgrade your dependency and switch to the new root API, then there's like a few very subtle kind of legacy quirks that we've gotten rid of, but everything will still be synchronous. And then as you adopt feature by feature, screen by screen, component by component, and some things will get a little bit into the more concurrent mode side of things. So if you want to start preparing today, since I think of it as there's some fixed upfront costs that you have to kind of take care of, and then there are things that you can incrementally do later on. So one of the fixed ones, like if you don't already have Node running, you might want to figure that out so that by the time you get to like later this year or whenever this happens, that's already solved. A lot of people are already in that world if they're using Relay or Apollo or something, or they're doing server-side rendering. And then what you can do right now, like today, is you can start getting your components to be strict mode compatible. So we have an API called strict mode that we released a few years ago that was designed to, in development, surface certain concurrency issues that so that you can solve them now before concurrent mode is released. So the basic things it does is it'll warn about some old class component lifecycles that that just don't really work well in concurrent mode. It'll warn about, or what a really important thing it does is it'll double invoke pure render functions only in development to try and like flush out any possible side effects. We have a whole document. I think a lot of people are already familiar with this, but a document describing like how you can start wrapping this strict mode around certain parts of your app to just incrementally get things migrated over. And that general strategy of like doing things like starting small and then gradually spreading it out until you have more of your surface covered is roughly how we're going to do it in post React 18 as well. One thing I think is important to emphasize is I think we might have been a little over pedantic in the past when communicating about concurrent mode compatibility. Like what we've realized converting like internal surfaces like Facebook surfaces to concurrent mode is that like a lot of things that are theoretical problems just don't really come up in practice that much. I mean, it is annoying when they do arise, But we've been able to convert like large swaths of our app with really not that many problems. So we are going to have like a way for you in, even once concurrent mode is out, to like, for instance, if you are running if you have some old class components that are running in a part of your tree that's not using any concurrent features, there's really no reason for us to warn you about that. So we'll have a way to either like opt out of those warnings and delay them until later once you actually do start adopting things, or use a strict mode component API to fix those ahead of time. But the general message is like, we're working really hard to make sure it's gradually adoptable, and you only have to pay the cost of migration once you start using new features in a particular part of your app. So yeah, short answer, if you want to start today, you can start using strict mode to fix those issues, and you should be hopefully very ready once the day comes to start incrementally adding features. The one other thing I'll mention is that there is my whole thing about how in practice you don't really tend to hit concurrent mode bugs. That is true of components and hooks. It's less true maybe of like frameworks or infra level code. So there will be some work. This is why we're planning to do a release candidate before we do a final release, because we're going to have to do some work to work with open source library authors, particularly things that do a lot of like state management type stuff or like read from external data sources. Those are the ones that tend to have the most like concurrency issues. And so that's really important for us to address, so that the ecosystem is unblocked from being able to, but by the time we go wide with the actual release, people are unblocked from being able to migrate. But the nice thing about, even though that sounds scary, the nice thing about that is if we fix, for instance, I'm just going to pick Redux. If we fix Redux for for concurrent mode, we fix it for everyone, right? We already did this with Relay at Facebook. Is like we fixed a bunch of concurrency compatibility things in Relay, and as a result, everything at Facebook that uses Relay, which is tons of stuff, kind of mostly just worked after that. Yes, hopefully that provides some insight.
The other part is kind of like around how you do data fetching today. So if you're interleaving data fetching kind of into a normalized store, then and you're mixing and matching state and data that way, then it can be hard to know like how to separate the client parts from the server parts. For a certain part of the app that you might want to keep that ability, but for the parts that where you're really thinking about server components could be helpful, it's nice to be able to split out the data fetching parts from the state parts. And I think a pattern that's particularly useful for that is get initial props or get server props in Next.js, because it's very clear that this is all the data that you need for kind of that initial rendering pass, or even like you could potentially invalidate it too. But and then for anything else that you need to do for data to be more dynamic, that's a different thing. So that pattern, whether you use Next.js or not, is a good way to kind of prepare, because you can mostly put all of your get initial props or get server props data fetching into server components once you adopt it.
I also wanted to add that in addition to the points that Andrew and Sebastian were highlighting, when server components are released in open source, I think we'll also aim to open source some of the internal lint rules that we've written, along with the conversion scripts that should help you get some of your components converted to server or shared components. For the conversion script in particular, it doesn't actually change your application architecture or like the structure of your component tree, but it will identify components that can be or are, I guess, server or shared safe. And if they are, then it tries to convert those components and does a bunch of like other stuff to make sure that like rename files are imported correctly and whatnot. But all of the points that Andrew mentioned, and Sebastian in particular, where if you can separate your client-side state with the data requirements, that will go a long way in helping the conversion script understand which components are actually server or shared safe, and then it can do the conversion for you. So we'll try to and aim to release these along with some server components. The timing may not necessarily match up, but we will, or I will, certainly try my best to do that.
And I think we're right about time to wrap it up. So I'd like to thank you all so much. Thank you, Andrew, Lauren, Sebastian, and Joe, for coming to answer the question. And huge thank you to Jae and Yanwei for joining us today and asking the questions. And I want to emphasize one more time that server components are in research and development. So we don't have all the answers yet. And what we said so far are just our kind of our best guesses at what the answers are. But as always, when we have something that we want like every React developer to hear, we will post it on the React blog. So if you check reactjs.org/blog, you will not miss anything important. But we still hope that this Q&A gave you a better sense of the overall architecture and the vision that we're going for. And if there is interest in the community, we also hope to produce more technical deep dives like this in the future that are centered on our ongoing research and development. Thank you for watching and have a good day. Bye.